Okay, time to start this. Initially, sorry about the technical problems. I was surprised that you are taking videos about the classes. It's quite good for one side. From the other side, I'm not totally sure if videos are the best option for you. Are you using the videos for studying? Yeah? Good, good. Like it. Okay. Thank you for the invitation. And I will be talking about DIgSILENT PowerFactory. I say DIgSILENT, there are people that they say DIgSILENT. Depending on if you are speaking in English or German, the pronunciation will be a bit different, okay? But the job today is talk about the software and how you will use the software for power system analyzing, okay? Before I start, I would like to show you a short agenda, okay? I will start with some motivations about using power system analysis software. I'm not sure if this is your first experience using software for calculations, but please don't be scared about using software for calculations, but also don't be overconfident about using software, okay? I know that the students, when they start to be familiar with software, they say, why the hell do I need to go to classes if the software is able to do everything for me? And to be honest, at the end of this session, you realize that the software is just a calculator, okay? Anyone can put a couple numbers inside a calculator. However, how many people is able to use those numbers to solve problems and to get proper answers from those numbers? That is the key word here, okay? Then I will talk about PowerFactory. I will go across the several features that we have inside PowerFactory. And I believe that you already took some classes about short circuit analysis or fault analysis. And I'm not sure if you are familiar with power flow. Are you familiar with power flow? Blood flow? Nothing like that? How the power moves inside power system? Yeah? Well, and at the end, I will show you what is the tendency now. I mean, PowerFactory is a very powerful software, but at the end we are using the software for more things, very complex things. And one of them is that we are using the software as a proper calculator using another software. Have you heard about software in the loop? Software in the loop is when you have two software talking each other. And the idea is that you can send orders to one, run some simulations, and then collect data and send back. That is something that is extremely useful. I will be talking about interfacing PowerFactory with other software, mainly MATLAB. Are you familiar with MATLAB? No? It's some sort of mathematics software, but also able to run some simulation for control systems. Are you familiar with Python? Python is I don't like Python, but it's a tendency for developers. For me, Python is not a programming language. However, a lot of people love Python, okay? Okay. Motivation about power system analysis. I will not take so much time here, but one thing that you must realize is power systems are changing. I mean, a few years ago, we used to say power system is a massive infrastructure that is generating electricity, transporting the electricity, distributing the electricity, and finally reaching the houses or the loads. And there is many challenges and many changes involving power system. there is something that is called the trilemma. Three main driving forces making changes in the electrical power system. One of them is energy security. Any one of you have an idea what is energy security? Any idea? Energy security is that you have enough energy to supply your customers, but also that energy is secure. A few years ago, we have problems with natural gas. Here in Norway, you have natural gas, but you don't use natural gas for heating, for instance. It's not typical. Here it's mainly electricity for heating. But in continental Europe, natural gas is the main energy resources. Could you tell me where is coming from that natural gas? Any one of you have an idea? Russia. And Russia is not necessarily the best friend of Europe. Energy security has been a concern for Europe for many years. And that is one of the reasons that we are pushing a lot for renewables. Climate change. I believe all of you are familiar. There are a lot of pressure. We are trying to reduce CO2 emission. If we don't install so much renewables and we keep producing CO2 so much, well, you will see 2 degrees, 4 degrees. There are many scenarios, but we have global warming. And finally, there is economic globalization. Now, markets, they are interconnected. Europe, Northern Europe, GB, and so on. And there will be a moment that all the markets will be connected, okay? That means that the power systems are changing. In 2000, I don't remember the year, 2014, I published a book chapter related with future energy systems. And that was the vision of the future energy system. What do you see over there? There is generation, those small arrows demand, but also a lot of renewables, electric vehicles. We have a lot here in Norway, southern Norway. In the north, I didn't see so much. Here, HVDC transmission systems. But what you need to understand is the power system is changing. Changing the way that we are producing electricity, more renewables, but also the way that we are consuming electricity. There is electric vehicles, there are batteries, we can store energy over there. And also the Tesla battery, if you are familiar, we can install batteries at home. What I'm trying to say is the power system is changing. And we need electrical engineers in order to run calculations and make the power system economically and secure to produce electricity and deliver to your home. Power system analysis is mainly designing, controlling the electrical infrastructure in order to deliver the electricity to the customers. May I ask you, what is the most complex system that the human being have created? What is the most complex system? Any one of you have an idea? It's not electricity infrastructure, okay? It's not. It's one that you use. Internet. Internet is the most complex system created by the human being. What is the second most complex? Any one of you have an idea? That is electrical power system. If you look at the continental Europe system, we are talking about 1,000 kilometers of transmission lines, many generators, many customers. What I'm trying to say is the power system is so complex that making calculations by hand is almost impossible. To be honest, digital computers have made progress so fast. And right now we have programs, software that can be installed in personal computers, and you can run calculations and you can get numbers in order to solve the realistic problems inside the power system. When I talk about power system analysis software, there are many software, okay? There are many software. There are two divisions. Some software, they receive the name commercial software. commercial software. They are expensive, but they are pretty good in terms of, let's say, security in the numbers that you get. They have been tested. They have been developed with a lot of money. You can trust on those results. There are few examples over there. Powerwall. A lot of students, they love this one. It's like a game. You can see it's very friendly. Here you can see a ETAP power station. It's mainly for industrial systems. If you are working in the oil industry or any kind of big factory, you will use this kind of ETAP. Here is the German competence to DIgSILENT PowerFactory. That is the PSSE, another software again for power system analysis. All the softwares over there, they are commercial software. They are pretty good. They have been developed by very, very knowledgeable people. However, there is two problems. First one, any one of you have an idea? What is the first problem when you are using commercial software? Any idea?
Expensive?
That is true. Those softwares, each one of them are pretty expensive. You are using DIgSILENT PowerFactory, good. The license for students is around 250 euros, 300 euros. But if you are using the commercial license, we can talk about 100K. Yes, because you are using a tool that you can earn a lot of money. I mean, to make money, to make money. What is the second property of those commercial software? It's something that is, they are pretty good. They have very good algorithms. They are expensive because we have many years of experience and a lot of people behind those screens. Every time that you put the button over there, you will imagine how many people behind making calculations in order that you get that software. But there is a problem. Because they are commercial, inside there is a lot of knowledge that you cannot put your hand in the code. I mean, you cannot make changes on the program. That is one disadvantage, especially if you are a researcher. And probably you will tell me, what? We cannot use PowerFactory for research. Yes, we can, but we need to do some other kind of approaches. We need to use another kind of approaches, okay? Commercial software, quite good. Expensive, but very complicated to do research. For that reason, they are non-commercial software. I didn't present anyone here, but there are many, especially based on MATLAB. There are many academic software developed by people like me. I did a few years ago. I spent 7 years creating software by myself with my students. Conclusion, this is better. I create my software for myself. 7 years later, we cannot compete. I mean, making a contribution, making better what is already better, so it's impossible, okay? Any question at the moment? Okay. I add this slide, and this slide made a lot of noise in LinkedIn. Because over there, many students, they feel frustrated. Because I am teaching equations, how to calculate a short circuit. To run a short circuit analysis, you need per units. Because you need to use per unit, you must be very careful with your phase connections, deltas, star, and so on. And the students say, why? If I have a software that I just press the button and that's all. When they know about power system analysis software, they believe, oh, this is amazing, this is the solution. However, PowerFactory is a calculator. A calculator, you put 2 plus 2, 4. How many people do you know that can use 4 to create money, to create solution, to solve real problems? Anyone can use this calculator. However, who can solve real problems? Students, they feel frustrated because you are showing the equations and going deep in the theory. And they say, but I have a software that do that. I don't know if you are familiar with the concept of garbage in, garbage out. Have you heard about that? In our software, in any simulation software, if you use wrong data, you will get wrong results. And if you don't have any idea about how the software behaves, about the physical theory behind the program, well, you will never solve the problem and you will never realize that you are making mistakes. That is the reason that you must first get the theory, be familiar with the theory, and then you will solve problems using software analysis. Please, don't be like this. I have been teaching PowerFactory training for decades. One of my challenges was I teach a medic how to use PowerFactory. Anyone. You don't need electrical engineering degree to press buttons. However, if you want to use the software in a proper way and use the results, you need to have a good understanding about power systems. Okay? Well, welcome to DIgSILENT PowerFactory. I must be honest, the original name was DIgSILENT, or DIgSILENT, as you prefer. It's a German company. This clever guy here, Martin Schmidt, around 1976, something like that, he was finishing his PhD. And one product of his PhD was a power system analysis software. I spent 7 years, he spent like 5. He created a software, but he has a vision. And he opened this company in 1885. The German company based in Kumbaninger in the south of Germany. And that company, the first product of that company was the software, DIgSILENT. But the software was the starting point that they also do, right now they are doing consultancy and also research. They are very, very involved in secret, okay? Probably the products, we can create 2 different products. One product is the program, the software, and that is PowerFactory. And the other product is something called stationware. It's something like a system to collect real-time data from the power system, okay? And below, there is a hardware. Probably 3 years ago, they go into the hardware area and they create something that is called the PowerFactory monitoring system. This is a device that you can install in any power station, substation, whatever, and you can get the data from there, and that data can go to this software stationware, and from there you can just see the data or send the data for further calculations inside PowerFactory. The company is big now. You can see over there, only few countries around the world, they are not using PowerFactory. I would say probably just few African countries, but it's around 140 countries. They are around 5,000 licenses, okay? However, something that you must understand is the software was created by DIgSILENT. The original name was DIgSILENT. However, they make a remake or refurnishment of the software a few years later, after 1885, and then they changed the name, and right now the name is PowerFactory. DIgSILENT is the company, PowerFactory is the name of the software. That is right now. And I say that is the name because DIgSILENT represents digital simulation and electrical network calculation program. The original name was DIgSILENT. Few years later, I remember, I think it was between version 13 to 14, something like that. They make a change in the philosophy of the program and then name that program PowerFactory. I don't know if you noticed, but I use the two words together, DIgSILENT PowerFactory. Okay? Just to keep the original name, but at the same time, respecting the ownership of the company. Okay? 13.2 and moving to 14 was a drastic change inside the software. Any one of you are familiar with software? Any one of you are good programmer? No one of you. Come on, electrical engineer that is no programmer. It will be a very good salesman. Okay? Please try to focus on programming. You will use that. Any moment in your life, programming will make your life easy. Okay? I don't say that if you are not programmer, you cannot be electrical engineer. No, I'm not saying that. What I'm saying is, if you are a good programmer, your life will be easier. Okay? Coming back here, they create a new environment inside the software. They change the way that the software look. That is the environment. But also the way that we put the data inside the software and process the data, and also the models inside the program. Right now, PowerFactory has many, many properties, but we can define three that they are the key points or the key features of the software. One of them is functional integration. Second, database integration. And third, vertical integration. This is a screenshot of the software. The software is, right now, I would say extremely easy to use. Probably too much. To be honest, I prefer some difficulty for the students, but PowerFactory right now have an environment, and this is the main window for the working area for the software. And right now you have here some toolbars. Every single icon here have a specific functionality. When we say functional integration, means that you have a single environment, a single software, that you are doing many activities at the same time, and the software is capable to do so. I mean, a few years ago, if you need to input data, you need a software. Then if you need to run a simulation, you need to find the specific software to run the simulation. Then when the simulation stopped, you get a file with the data, and then you need to run another software to create plots or to post-processing the data. Are you following me? Here you have everything together. Okay? That is one of the main features. Also, another feature related with functional integration is that you have a single database where everything is together, and you can use the same database for different calculations. Probably for you at this moment is something that is not necessarily so important. But to be honest, in the future, you will realize that keeping a single database will allow you to keep control about how the system is created and evolved. Also, you have the whole information in a single place. Okay? Then we have the functional integration. Here, you have something that is called the data manager. I mean, you have the database. The database is the core of PowerFactory. Inside is, you will find all the data that you need to perform calculations, like flows, short circuits, and so on. Okay, are you with me? That database is very, very important, and is similar to, have you used the Explorer, Microsoft Explorer? If you are looking for files in your computer, there is a small icon like a computer, my PC, double click, and you start to look for the files. Are you with me? Well, the data manager is something similar, to this software in Windows. But the main difference is instead of looking for files, you are looking for the electrical information of your system. In PowerFactory, we call that information projects. When you are using the data manager, you are accessing the data of different projects. And inside each project, you will have the specific data that you need to run the simulations, okay? I believe you will have a session for that. I think it will be very soon. Something that I suggest is the following. DIgSILENT PowerFactory is not necessarily the most friendly software that you will find in the market. I must be honest. This is created by Germans. And Germans, they have, let's say, a very organized vision about life. And if you follow rules, you will be very, very, I will say it will make easier your life, okay? One thing that you must understand, they are color codes. Every single icon inside PowerFactory, they are colors. Typically, they are two colors, red and green. But those colors, they have meanings. Also, every single window, you will find first name, surname, location. For instance, this is a synchronous machine. And this synchronous machine, the name is G1. And I will say the surname is ELMSIM. That means that is an element that represents a synchronous machine. I didn't tell you, but DIgSILENT PowerFactory is so powerful because it was created using C++. Any one of you are familiar with C++? Come on, tell me. Wake up. Any one of you is a good programmer in C++? You? No, not at all. Okay, if there is anyone good programmer, please approach to me at the very end. C++ is probably one of the most powerful programming languages. I don't know if you are familiar, but MATLAB is programmed in C++. Part of Windows, they are created using C++. C++ is an object-oriented software. Object-oriented software means that everything inside the software is an object. It's a very abstract definition. What is an object? Well, you can imagine an object like anything, but you can define by two important components, functionality and data. An object has at least two basic features. One is the data, and the other one is the functionality. For instance, this is an object, and this object is an element synchronous machine. And this object is a container. It's a data container. Here you will define, for instance, how many machines are connected in parallel, for instance. Are you with me? What I'm trying to say, this is an object, this is an element, but in the element you include the basic data that you require to define the object. Okay? Okay. Now I will complicate a bit more your life. Any electrical data inside DIgSILENT has two components. I spoke first about the green one. Do you realize that that icon is green, yes? And it's green because it's an element. You have the basic data over here, okay? Good. But then, this element is connected with another object. And this object has also data. But this data is different. This data receives the name type. Type synchronous machine. And probably you are wondering, why the hell do we need two different objects to define the same synchronous machine? Well, this is probably one of the most smart and intelligent inventions inside PowerFactory concepts. In one object, you have all the electrical parameters defining your object. Electrical parameters. When I say electrical parameters, is because you have a model, and that model requires constants, and that constants are used for simulation purposes. Are you with me? This one, the type, include that data. But if you are working with a synchronous generator, probably you need to define, okay, this generator is used, this data is used by 10 synchronous machines in parallel. And then here you have the data of 1. And then in the second object, you say, I am using 10. You don't need 10 of these to simulate 10 machines. What you are doing is using something that is the connection between one data set and the other data set. I need 10 synchronous machines. I go here and I take the parameters of one of them, and then I will use 10. Do you understand what I'm trying to say? This is extremely important. You are running in the lab, you will be running a power flow. Synchronous machines, they require both sets of data, the red and the green, the element and the type. Okay? Good. Vertical integration. What does mean vertical integration? I said before that the database includes a lot of data that can be used for different study analysis, power system analysis. Here, this is the type. Are you with me? This is the red color, the type. In this synchronous machine, we have here different type of data for different type of studies. The first data is the basic data. It's the minimum data that you require to put inside the object in order to avoid an error. The basic data that you need, apparent power, S, voltage, power factor, connection. Are you with me? But then, if you need to run a power flow calculation, what you need to go is here to this section and complete the data related with the load flow calculation. Are you with me? This receives the name vertical integration because for a single object, you can combine the data for many studies. And one important feature of PowerFactory is the data propagation. What does mean the data propagation? They are data that is used for several calculations. And if you put the data in one of those studies, and that data is used for another studies, automatically PowerFactory completes the data in the other places. Okay? Good. Well, remember that I say that you use the data explorer like the Windows Explorer, and you can find files, and you can find your videos or your photos or your Microsoft Word documents. Are you with me? PowerFactory has the data manager. This guy here is the project. The project is the big object. Everything that you need in your power system for run calculations is inside the project. Okay? However, the projects have a very important structure. They are something called library. Library, they include some objects that they are created by default, and they have specific uses. Then we have an object that is the network model. If you remember, you have a single line diagram, and that single line diagram, the transmission line, the generator, the transformer must be included inside PowerFactory. This section here includes all the electrical data inside your power system. What is the length of your transmission line? What is the cable used for your transmission line? What is the power demand in watts, for instance? Okay? Here, there is a section called study cases. Study cases are created with your results. When you make any calculation inside PowerFactory, PowerFactory creates objects. Those objects receive the name result objects. Results objects are objects where the data inside are the results. Okay? Are you with me? Good. Then here there is a section called settings. Don't put your hand over here, okay? I open over there the section settings. When you start to be a top user, probably you can put your hand over there, changing color, changing fonts, changing size, and so on. If you are not good user, don't put your hand over here, okay? Because you can destroy your project and you waste time, okay? Okay. When I was talking about the data manager, this is the icon. Every time that you open the data manager, there is a good news. You can access every single object inside PowerFactory. What is the bad news? I believe you are aware now what is the bad news. If you put your hand in the wrong place, you can destroy your file. But if you put your hand in a very wrong place, you can also make PowerFactory stop working. Okay? I just presented here the structure of your project. If you want to destroy your project, do it, no problem. Because you will start from scratch and do the thing over there, no problem. But if you go to settings of PowerFactory and you delete something over there, you can probably destroy the database and probably the software will not start again. Okay? Here you can see the general structure of the, I would say, the data management inside PowerFactory. We have single line diagram. That is the graphic representation of your system. However, you can have different level of detail. Very low level details going inside the components, looking into switches, looking into very specific details. Or you can go to a big picture if you have a system like the European system or GB system. You can have a bigger picture where you don't have the full details. All the details are inside the database. However, you just present what you need to present, okay? Here there are a lot of terminology. I will not go in details, however, I suggest that you go to the user manual of PowerFactory. Every single basic question that you have, the answer will be there. It's probably one of the best documentations that you will find. It's not like the Windows documentation. I don't know if you have any problem with Windows, but the documentation for Windows is horrible. Here, they spend a lot of money and time developing a very good documentation, the user manual. I highly suggest to have a reading over there, okay? Okay. Overview of power system analysis functions. PowerFactory do almost everything. The only thing that they cannot, the software cannot do is dance or kiss you, but this software in terms of calculation is doing almost everything. And every single year they add more and more functions, okay? Here I will present just a basic summary of the key features that you can find for PowerFactory. PowerFactory can do what we call a static analysis. What is the static analysis? Are you familiar with faults? Yes? Yeah? Come on, say something. You can say yeah, if you want. I don't know if I use the correct Norwegian accent, probably not. Are you familiar with faults? Come on, say something. Are you so bored? Come on. You are challenging for me. You are a challenge. What is a fault? Any one of you tell me. Come on, those students are letting you down. What is a fault?
Short circuit.
That is one type of specific faults. That is true. There are many more. Probably one that not much people know is open circuits. Have you heard about open circuits? We heard about short circuits. Why short circuits are so important? Any one of you? Why short circuits are so important? Sorry again?
Because of the high current.
Yes, and what's happening when they are high currents?
Form
And then?
goes up.
And what is really important that something like that happen and you're changing colors. Yeah! Why is so important?
Safety.
Safety, don't kill people. Yeah, good. What more? Why faults are so important. Don't kill people, important. However, I say electricity is one of the beautiful things. You can kill people and they will never see electricity. That is true. And if they see the electricity, it's probably the last time that they will see electricity. However, it's very important that we calculate short circuit. Safety, good. What is the second point? After avoiding killing people, the most important thing is,
Material damage.
oh yes, and that is,
Money.
oh yes, it's the same around the world, money. Yes, if you destroy a transformer, you are talking about a lot of money. Transformers are probably the most expensive equipment in one substation. Or generators are even expensive. Okay? For that reason, we need to run short circuit analysis. When we are running short circuit analysis, we are calculating what? Please tell me. Don't be shy. You can say anything. This is the only place that you can say wrong things, and I will not fire you. You will not lose your job. Tell me.
Currents.
Of course, the most important variable is the short circuit current, but there are also another kind of things that you need to calculate. What else? Why voltages? Why voltages are so important during a fault condition?
Voltages may occur that may make the system unstable.
You are going in very far direction, and also one place that I don't want to go, that is stability and power system dynamics. I don't want to go there. But you are, what is a short circuit by definition? What is a short circuit by definition? Come on, think about. Imagine where is a power socket here, there, yeah? I put my fingers over there. I am creating a short circuit. A short circuit, you require a potential difference, a voltage. And then I am including my fingers, low impedance. A short circuit is when you have a potential difference and you use a very low impedance. You close a loop, there is a big current, but that big current has very different consequences. One of them, heat flow effect. But also all the voltages inside the power system, they are affected. Some of them will go down, some of them will be high. When we are in low voltage, we say under voltages. When we are in high voltages, we say over voltages. This function allows you to make all those calculations for safety reason, for economic reason, okay? There are many functions that PowerFactory will make your life extremely easy. Load flow sensibilities, and for instance here, contingency analysis, quantity dynamics, blah, 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 blah. PowerFactory has at least, if my mind is correct, at least 25 different basic statics. And from there, you can go for different kind of settings, scenarios, network conditions, components. You can create own components inside PowerFactory. You would like to run a dynamic simulation for a wind turbine, and you can create the model of one wind turbine inside this model, okay? However, that is not for kids, okay? Let me keep going. 26, I was wrong. I say 25. I don't know if you can see over there, I spent a lot of time creating this slide because this one is one of the buttons that you will find inside PowerFactory. When you press this one with 3 different arrows, that is the load flow. Are you familiar with load flow? To be honest, a very famous guy, his name is Prabhakundur. Well, he's dead now, but he used to say, don't call load flow. Because the loads, they cannot move. I mean, if you have that light, it's a load. They cannot move. What is moving is the power that is running that lamp. Are you with me? That is the reason that the real name should be is power flow, no load flow. Okay? However, this symbol, 3 different arrows. What do you think that is the meaning of those 3 different arrows? Any one of you? Wow. The gym in Norway will be extremely hard. Come on, wake up. 3 arrows. We are running power flow. Power. How many powers do we have?
3.
Yes, that is the beautiful thing about electrical engineering. In mechanics, they use Newton's law. Force equal mass multiplied by acceleration. Here we have complex numbers. We have imaginary units. We have S, and that is no Superman. Who is S? S. Come on. Don't make me cry here. There are too many students. Apparent power is S. Then there is one that is called P. What is P?
Active power.
What is the unit?
What?
Sorry?
What?
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 No, I'm just kidding.
You understand the joke, yeah? But it's different because you have H. What? Okay. What? It was British. Well, to be honest, it was Scottish. He was the creator of the steam machine. And the third arrow, what is the third arrow? S, P.
Q.
What is Q?
Reactive.
Sorry?
Reactive.
What is reactive power? This is a meditation time, you know, to try to wake up. I need to go to the airport, but I have time here. What is reactive power? Come on. You are putting down the lady over there. Do you use the classical example to explain active and reactive power? I will not say a beer. Do you use the beer example?
I don't think I'll use it in this class, but I think they have a theory or something.
Okay, I will not use the beer because there are people that they don't drink. I don't care, it's not my problem. But you can use a Coke, okay, the drink, be careful. Oh yes, you laugh. You have a better comment in English than you are. Okay, the Coke is inside a can. Are you with me? All the liquid is inside. But you suddenly, and when you pour the thing on the glass, something really bad happens. What is happening there? That the liquid is now the creation or combination of two different things. One is in the bottom, that is the liquid. That is what you want to drink. And what is on the top?
Foam.
The ugly foam. Not much people want the foam. What is the foam? The foam is the consequence of a physical phenomenon. When you open the can, you release the gas, and the gas creates that foam. The foam, you must drink the foam because you are drinking the liquid. Are you with me? Well, P is what you want to drink. That is the active power. We want active power because active power creates real work. Are you with me? But when you open the can, you have the foam, something that don't want to drink. That is the reactive power. The reactive power is ugly. The reactive power is the price that you need to pay to drink the liquid. The reactive power is what you need to pay in order to get active power. However, what is S? Any idea inside your beautiful analogy? The can. When you have the can inside, you have everything. You have P and Q inside. That is the can. When you pour the thing, that is the process, okay? Probably you are thinking, why this guy is talking about drinking and this kind of stupid things? Well, one of the reasons is because in a minute I will tell you about power flow. And I would like that you have just a basic understanding about P, Q, and S. If you are planning to be a power engineer, I am a power engineer, no electrical engineer. I am a power engineer. Never forget what is P, Q, and S, okay? Don't disrespect me. From now, you must know what is P, Q, and S. Okay, over here, you can see the 26 very different studies. We have here the most basic. I will spend a few minutes talking about power flow. Then, you are already top expert on short circuits. Short circuit analysis. Then, we have contingency analysis. What is for you a contingency? Any one of you have a reason or an idea what is a contingency? Come on, basic understanding. What is a contingency?
What if?
Sorry, did you say something? Sorry, I didn't hear you. Yeah, too loud.
It is what if this happens, what do I have to have in backup?
Very good thinking. Sometimes something wrong happen. If something wrong happen, what are the consequences of that something wrong? Contingency analysis, you have your power system working like this. We are receiving electricity here. But what's happened if suddenly one transmission line is disconnected or one single hydropower generation unit is disconnected? Contingency analysis, they care about that kind of analysis. However, probably you are asking me, okay, why do we need a module, a very specific function for that? How many components do we have inside the power system? A lot. Which one of them could be the source of this continuous? To be honest, they are very interesting mathematical methods to calculate what is the most important continuous. However, we have the computer. They can do it. Are you familiar with parallel computing? Ah, my goodness. Let's see. Now you are using this is a surface. With their surface. What is that? Oh, oh, Asus. Which one is this one? Oh, good. You have over there what I need to. Sometimes you have a very powerful computers that people use for games. Over there you have something called GPU. GPU is a graphic processing unit. It's probably faster. It's not probably. It's faster than the CPU. When you are using for games, of course, you are pam, 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 pam. But you can use that for calculation. PowerFactory right now allow parallel computing. And you say, what is that? You have a GPU. GPU allow parallel processing. That means if you have several mathematical calculations, you can do in parallel all of them at the same time. What is the consequence? Reduce time. Okay? Quasi-dynamic simulation. Any one of you have heard about quasi-dynamic simulation? No. Have you heard about dynamics? Yeah. Where? You say yes. Now tell me.
For example, mastering damper system or something like that.
Very good example. Yes. Any physical system, you change color again, sorry, it's my fault. Every physical system, for instance, mass, spring, they have two different conditions. Steady state. We call that in PowerFactory static simulations. Static. Nothing is moving. For instance, you have the mass and the spring. Are you with me? Okay, that is static. We call that steady state. When we are solving circuits, do you remember circuit analysis? Yes, please tell me. Yes. When you are solving AC circuit analysis, what is the mathematical tool that we use? What is the name of this guy that is rotating and creating the beautiful sine wave? Have you heard about phasors? Phasor is a mathematical tool. Phasor is the mathematical tool that we use to represent sine wave. Okay? Are you with me? We use phasors because we assume that the sine wave is moving at constant speed. Constant rotational speed, constant angular speed. When we are working in a steady state inside a power system, we use phasors. Short circuit analysis. You are using Ohm's law, voltage divided by impedance equal current. Do you use phasors, isn't it? Yes. That is a static calculation. In a minute, I will talk about power flow analysis. It's another static phenomenon. Okay? If you have a mass and you have the spring, it's a system. It's a physical system. You can define this system as static because there are no changes on the height or the distance between the mass and the ceiling. Are you with me? Yeah? If you take a photo, you can say this is the static condition of this kind of system because the distance is not changing, nothing is changing. Power flow in a minute, PQS, remember? In a minute I will use PQS to define the condition of one electrical power system. Okay? Are you with me? Wow! We are finishing?
Sorry.
You bring no. Just kidding. No, it's okay. Well, it's not okay that you arrive at this time. What's happened to you?
Something.
Okay, we will not go there. Okay, there are 25 different types of analysis. The first two, short circuit and log flow, statics. But what's happened is somebody put the hand on the mass. Move the mass. And then release the mass. What will happen? Again. What will happen?
Move back and forth.
That is oscillation. You have a system. You use external force. You change the condition of this system. Are you with me? Suddenly, you remove the change and you allow the system to try to reach a balance. Do you understand what is the name of that condition? Any one of you in dynamics use mathematics to create the mathematical model of that? Do you remember the mathematical equation that describes that mechanical system? No? Come on, guys, a differential equation. Remember the differential equation using the Hooke law. This movement, these changes, wow. That is the dynamics. Every time that you change something inside the power system, for instance, the load, you are creating this kind of oscillations inside the power system. That is the dynamic. Okay? This is the section for dynamics, RMS and AMT simulation. However, I will wait if you reach the master degree, and I will be waiting for you over there. We can teach you more, okay? Because I need to go to the airport very soon. I need to talk to you about log flow or power flow. Remember that I was using names with the PowerFactory objects. Remember, ELM, SYM. That is an object, and that object is an element. And I say the elements, they contain data. Are you with me? Then I present the red color. The red color was the type, TYPSYM. That is the type synchronous machine. And I say that is another object. That object is containing data. Are you with me? At the very beginning, I say every single thing inside PowerFactory is an object. And there are some objects that they contain data, but also there are some objects that they can create data. Let me introduce this one, CMD. Any idea? What is the abbreviation, CMD?
Come on.
Good. And what is LDF? Well, it's not straightforward, but yes, it's log flow. Every single function that I present before, remember the 26 icons? The 26 icons, they are commands. Commands, every time that you press the button, they will create data. The object that contains that data is a result object, okay? That means this is a functionality. Okay, log flow. And my luggage is still missing. I arrived yesterday, and my bag didn't appear with me. For that reason, I borrowed this today. Okay, coming back to my explanation. What is log flow? We talk about power. Power is P, Q, S. To be honest, if you think about power systems, let me try to find an easy way a familiar way for you to understand this. You remember this? Yes, this is for kids. Circuits. You remember circuit analysis? Circuit analysis, classical problem. You know this resistor, you know this resistor, you know this resistor, and imagine that you know the current. And then you arrive in July. When is the exams here? The exams are in June or August? Exams.
Exams.
Yeah. What is the?
Semester?
Yes.
It's in 26th of November.
You arrive on November. Piece of paper in front of you. You got this. You got this data. This data. This. And then, for 20 marks, what is the voltage supply? Remember that? Circuit analysis, very stupid. 3 resistors in series, you get an equivalent resistance. Are you with me? Yeah, you remember that. Then, what is the mathematical rule? The mathematical rule that creates the relationship between voltage and current is the famous Ohm's law. Are you with me? Yeah. Then you apply Ohm's law, multiply this by that, pum pum, voltage, done. You solve the problem. You got your 20 marks in the exam paper, you pass. Are you with me? This is the most basic circuit that you will find. In every circuit you have known and unknown variables. I don't know if you realize, but every single device in that circuit requires one parameter, resistance, and 2 electrical variables, voltage and current. For instance, if you know this current, you multiply this current by this voltage, and you obtain the voltage. Sorry, this current multiplied by this resistance, you get the voltage drop here. Are you with me? What I'm trying to say is that basic circuit is similar to one power system. In a power system, you have generators. They produce the electricity. You have cables moving the electricity into the loads. You have a cable, you have a generator, and delivering the power. Are you with me? To be honest, a power system is a circuit. However, it's more complex than a circuit. Because in a basic circuit, the relationship between voltage and current, this is a linear relationship. It's a linear relationship. Remember that? Also, it's very simple problem because you are using algebraic variables. Are you with me? Good? But in electrical power systems, the situations are more elegant. You have here a node. Remember the nodes. What is a node inside a circuit? It's a connection point. It's a connection point of 2 or more devices. Are you with me? Good. This bus bar, every single bus bar can be represented by 4 electrical variables. If you know voltage and angle, you can obtain P and Q. Or if you know P and Q, you can obtain voltage. Every single node inside a steady state AC power system can be identified by 4 variables. If you know 2 of them, you can obtain the other 2. Are you with me? Okay. For instance, here, now we have something better than a circuit. Now we have a power system. This symbol here is a generator. one transmission line, one more transmission lines. This is equivalent to a node. Remember the node inside your circuit? Yes. Here we have a transformer, step down transformer. This beautiful arrow here is just a load. And here we have a capacitor. We have electrical power system. But inside the electrical power system, here we have a load. And this load is described by P and Q. Here we have another load, and that load is defined by P and Q. And here we have a generator, and in this case, bus bar number 4, we know the voltage. Do you understand that for every single bus bar we have 4 variables? 2 of them are known, 2 of them are unknown. Remember that. In the previous circuit, here I have 2 nouns. I can calculate the third one. In power flow, we have something similar. In power systems, instead of basic current, we are interested on how the power is moving inside the system. And to be honest, the mathematical rule that we use to solve the power flow is something called the power balance. Are you familiar with power balance? Power balance is a beautiful equation. Beautiful equation because all the power that I produce here, P, must move and reach this point and reach this point. All the power that is produced should go to the consumption. But in the process, when the power is moving across the cable, there are some resistance. And that resistance creates heat, power dissipation, active power dissipation, create losses. This is the basic equation for the power flow. The power flow is based on solving that set of equations, and those equations receive the name power balance. I didn't tell you, but I think you can see here the beautiful power balance. This is a node. How much is coming here? 59 point. And here, there are some power, yes, coming. And at the end, that power is going to this load. In this bus bar, you can apply here the power balance, but because there are no losses, all the power going in should be the power going out. It's the same here. All the power going to the bus bar is the power going out. Are you with me? I cannot go more simple than this. However, where the things start to be quite interesting. Here, we use linear equations for kids. When you have 3 or 4 years old, you start to play with that. Yeah, 3 years you can solve that circuit. And here there is no complications. There are no complex numbers? No. There are no differential equations? No. Simple. Linear equations, algebraic problem. But here, power for serious people, not for kids. And it's not for kids because first, the voltage in this bus bar, remember voltage? I say angle and magnitude. When I am talking about magnitude and angle, it's because I am talking about phasors. Phasors are complex numbers. When you use the complex representation, you are using the module, magnitude, and the angle. Look at here. P and Q. P and Q, you remember Superman, S equal P plus JQ. Are you with me? That means S is a complex number. But now I need that you have nightmares tonight. And this is the equation to calculate the voltage in this bus bar. Could you tell me what you can see in that beautiful equation? I love that equation. I will not go in complications now because somebody will explain you about the admittance matrix. It's not my problem now. I just speaking about PowerFactory. However, that equation is beautiful because that is a non-linear equation in terms of voltage. And because it's not a non-linear equation, now you need to use very interesting mathematical techniques like Gauss-Seidel, Newton-Raphson, and so on to solve the mathematical problem. Good for you. PowerFactory has the command blood flow. Remember the button with the 3 arrows. You press the button and you can say, I want to solve the AC load flow. And then I press execute. Voila, some results over there. The best case scenario for a student is that they press the button and they get results. They are happy. Of course, I got results. Yeah, I finished my coursework. Fine, I can go for parties. Good. But the worst thing is what's happening if you don't get results? If you got an error. And then you need to come back to the theory and investigate what can be the source of my problem. Because PowerFactory will tell you, you have an error. It's your problem, not mine. Solve it. That means that those equations that I am presenting here is not because I would like to show you something complex. It's because you need to have a basic understanding about this. Believe it or not, there is a famous mathematician. Have you heard about Laplace and Fourier? I will not say names because probably I can be wrong in history. But sometimes students, they sit down and start to solve the problem, blah, 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 blah. I remember one. We were designing a lightning system like this. And the guy approached to me. I finished. Okay, show me the results. 1.573. What is wrong? We are designing a lightning system. And the guy come back to me and say, 1.575. No. Some of you are laughing. Why? Why?
And 1.5 times?
It's more than 1.5. It's 575. He was perfect on the calculation. He used three digital places. Good. That's so stupid. It's 2. The answer is 2. You are probably laughing now, but there is a famous mathematician that he sit down and start to demonstrate what is the direction for the gravity. And at the end, the guy say the gravity is going in this way. Right now you are laughing again because you know that. And I have been in the position of checking consultancy reports for power utilities. And I say like you, this is crazy, this guy. I mean, if you put rubbish in DIgSILENT, you will get rubbish. And if you don't have a basic understanding, what is the direction for gravity? Everybody knows this. If I say to you 1.5, you will say, nah, this is. But if I say to you the rate of change of frequency is 7.5 hertz, or I remember a consultancy report that I read. Are you familiar with the wind turbines? You know, They are beautiful, especially for rock bands videos. But what is the weight of one of these blades? Any one of you have an idea? What is the weight of one of those blades?
60 tons.
Sorry?
60 tons.
60.
Yeah.
Again, you are changing color. It cannot be so heavy. It must be strong in order that they can absorb the force coming from the wind. But they cannot be so heavy. What's happening if the blade is so heavy? I made that mistake when I create a wind turbine. The blades were so heavy. What is the problem?
Long term.
It will turn, but you need somebody. You need a starter, because if you have so much mass, you have so much inertia, and they try to stay static if they are static. To be honest, a blade of 2 megawatts wind turbine could be 6 or 7 ton. But 6 or 7 ton with probably 40 or 45 meters, moving that, you require force. I was reading a report that the guys say that the blade moved from 0 degree to 90 degree in less than 1 second. And the guy presented the report that is impossible. 7.5 tons, rotate, move that. If you don't have a real understanding what is the direction for gravity, you will explain in your report, gravity is going to the top. That is the direction. And to understand the concept, you need theory, okay? Well, PowerFactory is going beyond that. PowerFactory, they can calculate solution for transmission system. Transmission system, we have a transmission line somewhere. Oh yes, we have one there. What is the main characteristic of well, this is not transmission system. This is 100 something, yeah? What is the word? 132. That is for kids. But it's a three-phase system. And one characteristic of the transmission system is that they are three-phase, and also they have very, very low resistance and a bit high reactance. Okay? R and S. However, sometimes we have distribution systems. In distribution systems, the history is a bit different because you can have 2 phases, 1 phase, or 3-phase system, all of them combined. And they create something called asymmetry. Or that means current and voltages can be different. To be honest, power flow, I solved the power flow over there using just a 3-phase system. And I say you need to use this equation, the power balance. And because the system is a 3-phase and balanced system, you say the 3 phases are using the same power. But in distribution system, you can have phase A loaded more than phase B or phase C. If you have B or C, PowerFactory have the possibility of calculating single phase, double phase, or 3-phase load flow. And also beautiful. This is beautiful. DC transmission systems. You know, here in Scandinavia, I will say we. I don't belong here, but I will say we. We have here in Scandinavia many HVDC systems. I think around 17 just in Scandinavia. Norway, Finland, well, they are not Scandinavia. I will not go there. Norway, Finland, Sweden, Denmark, we have around 17 HVDC systems. In this side, you have AC voltage. In this side, you have DC voltage. PowerFactory can do that. Beautiful. If I say to you, solve that by hand, wow, my mother will be in troubles. Another thing, PowerFactory allows you to use very different control modes. Remember the cam. Remember the P on the phone. Q. P and Q, they are very, very interesting variables. You can create Q using a classical generator, AC generator. But also Q can be created or produced in a synchronous machine. But the way that you create that reactive power depends on a control. Inside PowerFactory, you have many different reactive power controls, okay? Well, I will stop here about load flow because you will be running some load flow next week in the lab, okay? And now you are familiar with short circuits. Are you familiar with short circuit? Yes? I remember, what's happened here? Oh, yes. Hey, we have a video. Yeah! You know. It's there. No, this is a single circuit. Nice. You can use that to kill mosquitoes. I will stop this. Too much noise. First, short circuit definition. I remember that I asked you about a short circuit definition. It was not totally serious, to be honest. Every time you are future engineers, they are in third year, yeah? One more year and they will be killing people in the street. No, sorry. 1 year and you will be in the street doing your job, yeah? Are you with me? Every time that you are working, try to support your words. When you are a student, you need to make reference for your concept. Here, this definition over here is the formal definition for one short circuit, but it's based on the IEEE and the American National Standard Institute, ANSI. Try to be serious and formal with your concepts, okay? I don't need to do that because I have PowerPoint and the reference is there, yes? But in the future, please be careful. Something that you must understand, short circuits, you require low impedance. Something that is closing a circuit with a very low impedance. Second, you need a potential differential. Phase A, phase B. Short circuit, okay? Are you with me? What are the consequences of a short circuit? How beautiful. Have you seen something like that? This is a classical two-winding power transformer. Blue. Beautiful. You can see over there millions. Somebody must pay for that because that is very, very sad. Somebody make a mistake. Somebody make a mistake because those devices are so expensive that they have some equipment that they receive many protections. Protections, like the protections that you have at home. If you make a short circuit, the breaker go down. Okay, are you with me? Somebody make a very big mistake. If you have protection here, this will never happen. Or it's something that you never calculate. Somebody make a mistake. Okay? I remember that I say to you, excessive over voltages. There are many different types of short circuits. Single phase short circuit is the most simple. Somebody approach to the line, take the line, phase to ground. Are you with me? Face to face is probably not so frequent. 2 phases. And 3 phases, I cannot imagine a crazy guy trying to take the 3 cables at the same time. It's almost impossible. However, it happened. I have a video that I don't have time to show you, but I have a helicopter. 3-phase short circuit can happen, okay? They are very rare and infrequent, but they can happen. When you are making short circuit calculations, you must assess all of them. 3-phase, 2-phase to ground, double phase, single phase, okay? What is the idea? You must know which one of them is the worst. The worst case scenario must be prevented, okay? I am tired, and I don't have coffee here. I don't know if you're familiar, but in power system, there are 2 main areas. One of them is planning, the guys inside the office, air conditioning, where here in this country is heating. Yeah, you don't need air conditioning here. But inside the heating, you know, making calculations. That is planning. Planning has two important areas. When you are designing, you are doing planning. You are creating a new station in 20 years' time. Somebody must spend millions, you must make the calculations, you must be sure that everything is fine. Are you with me? But also, you need planning day by day. For instance, if you need to know what will be the power production for the next day, you are running a simulation for the next day. It's something that we call offline. Here is the people that they are running inside the heating system. Those guys, they have also heating. The guys in the control room, they are playing with the power production, creating the balance. Those guys over there, they are trying to keep the balance. Remember the power balance between generation and demand and the famous losses. Well, they are trying to do that. For planning, I need the short circuit levels, because I don't want that transformer going on flames. I don't want a circuit breaker exploding. I don't want somebody dying, okay? But also, in the operation, second by second, I need that those protections, they must be able to see if there is a fault or not fault. Protections, believe it or not, they are control systems. In control systems, you have measurements. From the measurements, you take decisions. But the decision here is very simple. Simple, but very expensive. This guy is sitting, taking measurements, current. Okay, there is no fault. There is no fault. If the current go above a threshold, oh, this is a fault, open the circuit breaker. That is the job of one protection. The protections, today we try to use the word smart for everything. Smartphone. And we have people that they are not so smart using the phones. And we have smart chargers. And we have smart things. We need to see smart people, okay? Protections are not smart. Protections, they require settings, at least now. I mean, we are working in something called intelligent and smart protections, that they are able to adapt to the system. However, at the moment, if you go to a substation, you need a protection, and that protection requires a setting. From 2 amps above, that is a fault. 2 amps below, everything is fine. And the guy that is responsible for that calculation, hopefully will be one of you, okay? Well, I don't know if I say hopefully or not. Okay, here there are different types of short circuits. PowerFactory has many types of short circuits. 3-phase, double phase, blah, blah, blah. Also, you can include the arc, the short circuit arc, the impedance. But also, if you go to the master degree, I don't know, do we teach here standardized short circuits? IC 60, no. I don't know in the master, but there are something called standardized short circuits. Few years ago, the industry said we need to standardize all the protections and all the devices. And the Americans, they go for the ANSI C37, and the Europeans, we go for the 60909 European standard. Okay? This is mainly for commercial purposes, but DIgSILENT do that. Okay? Well, we are almost finished. Are you sad? No, I can see your faces. We are finishing this torture. We can go. One of my book, please forgive me. In my luggage, there are a couple books that I bring with me in order to show you and so on, but the luggage is lost. As a consequence, I don't have the book. But this is one of our books. In 2000, I believe it was 2016 or 17, we published that book. Chapter 15 of that book, it's called Interfacing PowerFactory. Remember that I say to you, PowerFactory is a calculator. And sometimes you need a low skill individual pressing the buttons. And to be honest, I don't want to use a monkey to do the job. Or you can use this. Instead of using that, you can be clever and you use software. PowerFactory is a power system analysis tool. They deal with networks, power systems. They can run simulations in a steady state like load flow, like short circuits, but also for big hits, dynamics, okay? PowerFactory has something called interfaces. Interfaces means that you can talk with that interface and you say to that interface, tell to PowerFactory to do this. They are very different interfaces with very different purposes. For instance, students love this, MATLAB, because it's simple. They prefer MATLAB to talk directly with PowerFactory. In a minute, I will tell you that is probably the worst decision. C++, pleasure, hopefully it's not contagious. C++ is probably one of the best programming language, serious programming language. You can use DLL, that is a library that you can create using C++. And with them, you can talk directly with PowerFactory. This is the Simulink MATLAB PowerFactory simulation. Okay, what we have is a very short script in MATLAB. We have any kind of model in Simulink, and when we run the simulation, you must go here, pass data from here to there, then pass data from here to there, solve something, get the results, come back here, then come back here. What is the main disadvantage that you can see? Very basic. Speed. You need to go here, then go here, then go here, then back. I don't like my students using MATLAB Simulink in this way. There are other ways that we can use for PowerFactory. However, there is a chapter in my book about that. I prefer this one, but you need to use DLL. Are you familiar with DLL? Your computer has a lot if you are using Windows. DLL are libraries created using C++ or any other kind of programming language. You can program over there what you want to use, what you want to do. And PowerFactory, because it's created using C++, they can speak directly to the DLL created in C++. And do you imagine what is the consequence? Like 24 times faster than using any other kind of approach. Finally, I don't like this one. PowerFactory has something that is called API. Are you familiar with API? API is a piece of software that you can use for download data or to communicate with another software. APIs, for instance, if you are you familiar with Twitter? Yes, Twitter, a small thing. Twitter, you can collect the data. You can make a search, a very deep search, using Python code, and then you send the code to communicate with Twitter, and you can download, for instance, people that use my name. That is called Gonzalez-Longatt. And you can download all the tweets that somebody used my name. Probably you are wondering, well, and what is the good thing over there? That you don't need to be a programmer inside Twitter. You can use an interface, deal with Twitter, collect the data, or do whatever you want, and you don't need to be inside Twitter. What you are doing is talking to a software that software can talk with Twitter in the proper language, and you can get what you need, okay? Python is one of the APIs. My students love Pythons. I don't like it, but well, I use it. Okay. Conclusion. PowerFactory can do almost everything. I say to you, it cannot dance. Sorry if you like dancing. It will not kiss you, sorry, or hug you if you want kisses or hugs, sorry. But in terms of power system analysis, I have been using PowerFactories for, it's not good to say a number, but for a very long time. And I must recognize there is not so many other software that could be better than this one, okay? I don't have any commercial relationship with PowerFactory, okay? They are very good friends of mine, we have communication, whatever, but it's one of the best software, I must be honest. I tried to create my own software, but it was impossible to be better. And at the end, if you cannot win, what do you need to do? Yeah. Finally, I know that you are, I think you have some assessment, some game to play with the software and so on. Over there, I put few links that probably will be helpful for you. So, not much people know, but PowerFactory, DIgSILENT in Germany, they have an area that is called frequent question and answers. They have very good information over there. Probably, I'm not sure if it will be helpful for your level, but if you are thinking about future projects and you would like to go deeper, they have very good information over there, okay? Here there is a YouTube channel. PowerFactory have DIgSILENT PowerFactory have a YouTube channel. You can see videos over there. Also, the software have tutorials. Also, the software have videos, okay? I am the administrator of 2 different Facebook groups for DIgSILENT PowerFactory. The group over there is in English, okay? Probably you have Facebook. Yes, I know, I don't like Facebook also. But what you need to do is use the tools and try to take from the best of the best from the tool. In that group, I have more than 3,000 users. And inside the users, they are original programmers of DIgSILENT from Germany. And they are people from DIgSILENT in other countries, including Australia, Spain, and so on. That user group is quite good, okay? And the administrator, and before I start to make stupid questions, I don't know why people go to the forums, and what they go is jump directly. What is the name of this group? Come on, go and see the other post. They are searchers. You can put over there the question or the phrase that you are looking for, and that group has been for 5 or 7 years. There are many of answers over there. These are very old slides of me. I don't believe my slide for load flow will help you so much, because I am more into the other complex stuff. Power system dynamic, renewables, HVDC, electric cars, batteries, and so on. But I believe there are a couple slides over there that can help you for load flow, okay? And finally, there is a guy in DTU Denmark, the Danish Technical University. He's Italian. Martinelli is his name. He's Matthias. He created a YouTube channel for one module that he's teaching in DTU. And I think it will be very, very helpful for you. Because I have very bad voice and very ugly accent. And also I am lazy, I don't create videos. I have a YouTube channel, but you will find my presentations in other languages, and also I have few about PowerFactory, but I don't like creating videos, okay? 2 p.m., 2:05. I need to run to the airport, but if you have any question, I will be extremely happy to answer you. There is something called ResearchGate. Are you familiar with ResearchGate? Oh my goodness, I say Facebook and I say Snapchat, yeah! I say, what else? What people is using now? Snapchat. I don't be seen. There is something called ResearchGate. You know, normal people, they use Facebook to show the photo, the video, the cat and the dog and the things. Academics, we have a Facebook, but instead of publishing photos, we publish papers. And you can go over there and you can find my name and you can find all my papers, and also this presentation will be available over there. I will share with your lecturer over here. But I highly suggest, if you are planning to do serious research in the future, open an account. It's not like Facebook, right? You will never put over there a cat, you know, leaking, whatever. You will put papers. But also, if you need one specific topic, you can find that topic, and also you can make questions. There are a couple of groups in ResearchGate about PowerFactory also, okay? Any question? Oh, come on, there is no question. I always say there are two possible reasons that, oh yes, the Guinness is speaking. There are two reasons that people don't ask questions. Do you understand everything, or do you understand nothing? Which one of them I most assume? Okay, any question? If not, I close this and I will run to the airport. And probably I will hear the Queen's speech.
Thank you.
So, thank you.
Let's have a 15 minutes break.
Yes, I need it.
Have a short session with you. Thank you.
No, thank you. Thank you very much. Thank you for inviting me. Don't invite me more. No. Just kidding. Yeah.
It was very interesting, very interesting. It's, they don't talk so much.
Yes, I can see.
Typical Norwegian.
No, but we need to open them up. I mean, we need to prepare them for future work environment. And I think it's a good idea that they do more. Yeah, that's bad. I enjoy it. What about you?
Yeah, I really enjoyed the. I am not familiar with the program.
Oh.
So I'm looking forward to learning it. Trying to get time.
Let me close the video here. Yeah.